No, you really don't want it. No. Leave it back here. Okay, let's take a look at this here. Let's see.
Really?
What are we thinking here? Trevor, start us off. What do you think? Differentiating this quotient. What's the first term going to be?
First term?
Yeah.
X squared plus 1.
X squared plus 1. Good. Oops. I did read. Wow. Oh, it's on freeze. No wonder. That explains it. There we go. Okay, so quotient rule. Up here, please. Quotient rule: bottom times. Okay, bottom times. Derivative. Okay, derivative at the top. Good. Okay. So that's going to be what? Okay. Minus. Very good. Minus. That's important.
Oh yeah, I have that.
Yes.
I have that. Totally have that.
Okay. What's next?
5x minus 2.
5x minus 2. Good. Quantity 5x minus 2 times.
2x.
What's the derivative of the bottom?
2x.
2x. Good.
2x.
All divided by squared. Good. Quantity x squared plus 1 squared. So we're done with calculus. Last step would just be to clean that up a little bit. It looks like there's, but what could we do to simplify that? Okay, we could expand the top just to combine like terms. The bottom, I mean, we really don't want to expand the bottom. We'd rather just leave it factored. Okay? And you might say, well, why not the top two? Because the top's not factored. Does that make sense? Right? So on the top, we can distribute the 5, we can distribute the 2x. And if we do that, do a little mental math here. See if you can, everybody see if you can do this. Maybe only one person will say it, but see if you can all do this in your head. What are we going to end up with? Now, bottom's done.
Yep.
X squared plus 1 squared. What are we going to get on the top if I distribute everything and add like terms? Okay, good. So the x squareds, we're going to get a positive 5x squared here. We're going to get a negative 10x squared here, right?
Yep.
So there's a negative 5x squared plus 4x. Good. So we get a negative times a negative is positive, right? Remember how that works too. You can count the number of negatives that are being multiplied in any term. And if it's an even number, it's going to end up being an even answer. If it's an odd number, it's odd. Or it's negative, sorry. So plus 4x plus 5. And that's it. Okay? Good? Good. All right. Throw another one at you here. How about something like this? Let's say,
No, because
say we got,
you have to distribute.
okay, differentiate that.
Oh, yep, I can do that. Yep. Are you serious? Okay.
Okay, this seems like a pretty easy one, but there's an important and very important moral to this story. Do we need the quotient rule on this one? No. In fact, should we use the quotient rule on this one? Absolutely not. The quotient rule, now, how come? Quotient rule is sort of hard, isn't it? I mean, there's a lot of steps, a lot of opportunities for mistake. Think what the quotient rule means. The quotient rule is for differentiating a quotient of functions, right? If I've got a constant on the bottom, big deal. Dividing by 6 is the same as what?
Multiplying by.
Exactly. So this is the very same thing. I don't have to write it this way, but I have to at least think of it this way, as 1/6 times x squared plus 3x minus 2. And what do we do if we have a constant out in front when we're differentiating? Well, maybe at the end possibly, but we just leave it there, don't we? Right? We just leave the constants out front and differentiate everything that has a variable in it, right? So, so if I have a constant on the bottom, just leave it there. Just differentiate the top and either leave it there or pull it out as a fraction. Take your pick, same thing.
Same thing.
Okay, make sense?
So that's it.
Well, we're not done, but, so we'd have that 6 on the bottom. What's the derivative of x squared plus 3x minus 2?
2 plus 3.
Now we're done.
Okay, so we still got the right answer.
Yeah. Mm-hmm.
Alright.
But it's a lot of extra work.
Okay.
Yeah. Yeah, it'll work. Okay, how about this one?
Right there. That's what that is right there. It's gonna be dirty. Yeah, I was gonna say that.
Okay, differentiate that. Okay, do you want the quotient rule on this one?
Yes.
Does it seem like you should need it on this one?
Yeah.
Remember what we said, the quotient rule is for a quotient of functions. Is that a quotient of functions? No. So I shouldn't need the quotient rule. The quotient rule is only when I've got x's or whatever my variable is on the top and the bottom.
Terrible, right?
Ross is showing you we're live here.
I roll like this and it stops.
Oh, that's what I got right there.
I got an 8.
Oh, shoot. Yep, that's the 6.
Okay, so what's
Yep,
the
yep.
what's the
So
trick
that's
here?
still the 4.
Exactly. Okay, so here's another real important story. Make everyone's attention up here. I want everybody to see this. This is big. If you have a constant on the top and a power of x on the bottom, you always, I mean, you could use the quotient rule again, it's gonna work, but you don't wanna do it. It's a lot of extra work. You always just rewrite it as a negative power and use the power rule.
What's the power rule again?
Remember, that's the one where we bring the exponent out front and
Okay.
subtract 1 from it?
Oh.
Okay, so what is y prime in this case then?
That's right.
That would have been negative 18x and negative 1.
Good. And if you're asked to write that without negative exponents, that's okay. Just put the x to the fourth.
Kind of what's going on.
Where's the negative?
Okay, the negative from the negative 3, we'll bring it down front.
Okay, it was like really weird.
That's
cute.
right there.
5x 24.
Oh, yeah.
Okay.
What in the world?
All right, were there any other questions on that assignment, or does that cover it pretty much? Okay. I think we're good. Maybe we'll, did you have one?
Yeah, the